Me. So who am I? The summary of this slide is I'm a nerd. Been in IT forever. Currently I work out at Stennis with General Dynamics IT. 12 years as a ham. I'm 48. And I'm a general class, so I have some room to learn, and I've been learning. I don't know it all. That's really one of my major factors for doing this and being a ham. There's always something to learn. And there's great people in our club to learn from. And my extended club, which is out in Jackson, Mississippi, filming in the back right now. You guys might know me from the Amateur Logic TV show as the cheap old man, which also fits into the SDR range, which we'll see in a minute. I work with Professor Thomas there in the back and Dean Martin, Tommy Martin out of Jackson, Mississippi. They do Ham College as well as George does the Ham Nation. I am a member of the Ozone Amateur Radio Club, the ARRL, CureZ, Cellcoms, and the D-Warren system down here, Aries, Skywarn, you name it. I just immersed myself into it. In fact, I think I talk to Rick almost every week as a result of that. So that's who I am, a nerd. Proud of it. So here you see the chart again. The NTIA publishes this chart. The reasons, or to point out the reasons that kind of drive me towards SDR and the use of them, or what's the possibilities. Because a long time ago, I set out to try to figure out, it's an obsessive compulsive ham thing. Is there stuff on all of these bands that I can hear, that I can decode, figure out? What's going on out there? It's huge. That is a picture of one of the reasons that drives me through to use SDRs to figure out what's out there. For instance, something that's unidentified to me. There might be something on one of those bands in that chart that's being broadcast. I don't know what it is. It's a beep, it's a boop, it's a signal spike on a waterfall or the spectrum scope. But when I find something unidentified, it's a challenge. I use that as, hey, I'm going to go figure out what this is. So that's where the SDRs come in. It's visual. I don't have to sit there and turn the dial. I'm looking at the whole band or a big chunk of it, and I'm seeing the entire thing. So those spikes become something I can click on, zoom in on, and help me with my mission of figuring out what's out there. That's just who I am. Once I find that signal, is there anything in it? If so, what do I need to decode it? What do I need to figure out what's in that signal? If it's voice, it's one thing. What are they talking about might be the next question. But if it's digital, it's a whole nother realm. Is it obfuscated? Is it, And this is not just about ham. It's about the radio spectrum in general. So SDR has definitely helped me along those lines. What equipment's necessary to figure out? How do I get it? Sometimes you might need a computer, like a Raspberry Pi or a full-fledged computer just to run the software that's required to become a part of that or figure out what that signal is. And then, of course, with things like the AmateurLogic.tv show, we'll share it. We'll figure out, let's put a video segment together and share it out, what we learned about that from that SDR or from using it. That's one reason. Another reason is really about you guys. The people in ham radio so far, from my experience, are pretty awesome as far as when, there's problems just like with anything, but I try to avoid that. We've all seen politics, I think, in radio and the clubs and maybe the organizations that are out there, but I don't focus on that. I stick with the figure out how to do what I can do and share it, spread that goodwill. And the way I do that is through sharing what I learn about things, and SDR has helped me do that. It's visual. It's actually, oh no, here it is. Here's how to do it. And Mark here up front was asking me today, what do I do with the antenna? It just so happens that George's field day segment in our videos showed exactly what's possible. At work, I'm sure you guys may have seen your networks converging with your telephones converging with your IP networks or internet-bound services for remote Work at home, there's all sorts of conversions happening. It's already happened. We're in that revolution already. You can work from anywhere on the planet. And to me, there's no difference in what's happening in ham radio. It's just we're a little bit lagging behind some of that speed or the technologies because of the rules and things. But I think SDR might be changing some of that. And speaking of services, what it all comes down to when we're a ham, we're in the amateur radio service, which is a bunch of bands that have been set up for us to provide either a backup to or an alternative when all else fails, right? So I think SDR's breaking into what can we do with doing this. I want to say the other day on Ham Nation, I saw Amanda was talking about becoming somewhat of a monitoring service using their MCOM van, where the agencies they're serving can't listen to everything. And Amanda was talking about actually listening and providing some of that information to the people they're serving because they can't hear it all the time. So it's neat stuff that's, I think SDRs will kind of help. Another thing that drives me is something that I saw in Ham Nation episode number 405 from Dr. Tamitha Skov. Anybody know who that is? You've seen her or heard about her? The weather,
Space weather woman.
The space weather woman gives predictions of the sun's effects on Earth, whether it's interfering with GPS or assisting amateur radios or knocking it out completely, whatever it is. She writes a weekly video cast or monthly, I forget how often it is, of what's going on. Well, she was also on, I think it was Hamvention. She was talking to Bob Heil and he introduced her, and she mentioned something about the sciences of radio and how we could possibly inspire that next generation on the uses and the techniques that can be had. Now, she was using a pretty far out topic, like, the next people who are going to go colonize Mars, they're not going to be able to bring their cell phones and have them work while on Mars. Or maybe they will. They might have that Mars cell network, but the concepts, some of that starts right here. And that was fascinating. So go give it a look if you want to hear an interesting look at what that is. But it's all about inspiring people, right? We try to bring people into the hobby for all kind of reasons. So that's one other reason that drives me towards looking to see what SDR. We can organize people, networks of people to serve for all kind of things. Humanitarian, government. Rick, here, you're the EOC, right, down in Belle Chase, so, we're already doing that and doing things. And of course, these guys are doing that same thing, promoting what's happening in the hobby. Let's talk about SDRs. So SDR radios, you have normally an analog or continuous signal coming in. It's going through some components that are also processing in that same domain, if you will, of time, which is continuous, and going through filters. And this is a standard setup. And eventually, so you're coming in analog, and you're winding up going out analog. Anybody know who that is over there? So he has an album actually and a song about him being an analog man. So there's a typical analog radio like we all probably have. My ICOMs, all of my radios right now are pretty much, they might have some digital components in it for noise reduction, but the processing of the actual signal through it is an analog path, okay, which is a little different than the SDR. In the SDR, of course, that signal is still analog coming in from your antenna, but it's hitting your hardware, and all of a sudden, it's hitting some components that are actually sampling or digitizing that analog signal and converting it to digital at that point. Just like people did with music and audio frequencies like rap music or dance mix music type stuff. They're digitizing these sounds and playing them back. It's same things happening on RF in these cases. So you got the analog signal coming in, you're digitizing it, and then running it through software. Hence the term software-defined radio, right? There's something that's processing in there and acting like those components or blocks of the analog radio. That's where the software part comes in. It's actually processing Now that it's digital, it's been converted from analog to digital, ADC, it's actually going to process that information through a software that's organized like the analog used to be. So that's what this slide's all about. It's taken in, this is just two different views of the same type thing. Signals coming in analog, it's being converted to digital, and then processed through software, and then we got to hear it some kind of way, so it comes back to us as analog AF audio frequency. So that process of actually converting the RF that's coming into our antennas, just a high-level overview, is taking dots over time to represent what would normally be a continuous signal or sine wave analogous input. So you're taking little points that represent that signal over time and then feeding that to the software. So with that in question, anybody know who this guy is? Oh, who is that, George?
That's Moore.
That is Moore, I don't know.
He made the law on...
The number of transistors in a microchip doubles about every 2 years, but the cost of that computer is cut in half. So you can see this little chart here. It's really flowing, back in the, I don't even know when that is, a long time ago in the computer history, to close to now. And that's still going. I don't know that there's an end to it. I mean, I think they're grappling with size and miniaturization problems right now. They got it down to the atomic level. So yeah, okay, he's a co-founder of Intel. But that's what Moore's law is about. Why is that important for us? Well, we're talking about SDRs. I mean, the power of a computer is going sky high, the speeds of the processors. Hence the reason now I can buy an SDR that's pretty darn powerful for $200, $150, sometimes $20 or $300. Not cheapo man compliant, by the way. It's very appealing. It's very appealing that this trend continue, yes. And there's no end in sight, and it's exponential according to Moore's law. So that's kind of hard to read, so I'll do it. What should we be getting out of SDR? What are some of the things that are out there? I did some research and found there are some things out there that might be familiar to some of us. Spread spectrum technologies and ultra wideband techniques. Well, all that means to me, and I know you guys might know more about it than me, but they're spreading the same signal across multiple bands, possibly even multiple types of services or radios. You're spreading your signal around. And because of the computing power and the capabilities, like the digital stuff that's happening now, that is supposedly becoming more achievable and better. So that is an actual promise they are putting on an SDR platform to try to figure out if they can make that better. Because of its capabilities of detecting and correcting errors and the speed of the computers, they're saying that's why it might become better. Software-defined antennas. Okay, now that's an interesting thing. I'm guessing what they're talking about is somewhat like what our cell phone carriers do right now. They might zoom in, they know my phone's here, directional-wise, from their networks of towers, and it might send a signal or focus that beam of energy towards me more to help that happen. I'm thinking that's what they're talking about there, because they pretty much say something about a directivity so that the receiver, or maybe maybe it's too much power and it can turn its signal down and use less, where the antenna is being phased or adapted to give me just what I need, which is pretty cool from a ham radio perspective, because that's compared to a CB radio. Maybe that's what we do. We see how much we can get away with the least amount possible. QRP, cognitive radio. So there's different radios across different services that are basically all talking to each other, trying to figure out what's my best path. Well, I know we do that using a service like WinLink. WinLink does HF propagation prediction on the fly to tell you your best bet within 80% of hitting another station in Texas is blah. It's taking real-time HF data, propagation, sun factor indexes, and predicting what your best path might be. So cognitive radio is an interesting promise of SDR. Dynamic transmitter power, I think we just talked about that, where it's adjusting based on, it says something about a near-far problem, but the idea is the same to me. And then there's the last one, which is wireless mesh. You know, our services have kind of been piled next to the military's services, if you noticed. I don't know if anybody noticed that. In World War II, I guess we were kind of like a backup plan, or our equipment and us. Right, listening. So yeah, because we all know the HF is going to leave the country in certain propagation situations. That's right. So anyway, the reason I brought that up is because I kind of see this is a vision, this is a futuristic vision, at least something I see. We've always been kind of a backup service to that HF segment, whereas now the proliferation is the internet, right? Instant connectivity to the internet. And there are entire communities out there right now who are point-to-point linking themselves together in mesh networks using ham calls and techniques, if you will. TCP/IP protocol. I think this is in Dallas, but there is an entire network, point-to-point, 2 gigs, 5 gigs networks that are TCP/IP networks, not dependent on the internet. They're talking to each other and doing stuff like phone connectivity, VoIP, or all those converged technologies we were talking about before. So I kind of see us becoming that last backup to connectivity. So what does it mean for us as, continuing along that, besides all of those other promises that I've researched? We can see the benefits already. From ICOM's rigs, you know, they're saying this is an SDR, and they use a different term called a direct sampling, which is the sampling we were talking about earlier. It's sampling the RF coming into your antenna, not audio frequency, but RF. And piping that into an FPGA, field programmable gate array, which all that means is it's a chip that can be reprogrammed on the fly. So software, in other words, in the chip. And so their claim, this is the claim, and I don't know exactly what this means. Again, maybe what some of you guys might know. It says it's capable of 100 dB RMDR, okay. Yeah, I'm sorry, yep.
Reciprocal mixing dynamic range.
Dynamic range, okay. So improved dynamic range that almost rivals their top of the line analog rig, right?
Yeah.
Yeah.
That's over $10,000 more.
Right. So you got a $3,000 radio or $228, whatever this costs now, that's competing with its $10,000 analog cousin because of SDR. All right, so there's that Moore's Law thing coming into play, and if they could figure out how to get it packaged, it's going to benefit us in this method. So we talked about that field programmable gate array, and I just kind of threw this slide in here. At my house, I have a shack that's over the 300-foot limit away from my house for copper, and I didn't want to run fiber in my backyard. My dogs would love that, I'm sure. So, yeah, Rick always feeds his four-legged friends. He knows what I'm talking about. They'll eat it. I have a point-to-point link sitting in my backyard of Ubiquiti systems. It's a 5 gigabit link that gives me about 650 megabits of throughput. And it's the same way. I've had at least 6 to 7 updates to the software, and not just a firmware update like you might see on a computer's BIOS, but the actual entire software that's running on those point-to-point dishes in my backyard. And these things are rated, the ones I have are rated about 20 miles, and they'll guarantee you're going to get 200 meg of throughput even at that rate. So the software part of that is an FPGA, which they can just load another firmware version. Oh, we fixed all these problems. Or, hey, we added an entire function that didn't exist before. Now that's interesting to me, because you have a hardware platform, but yet they're adding buttons and knobs to it. You know, think about that. Software-defined radio. So there are limitations based on the hardware still that you fight with. They can't add something totally different that it can't do from a hardware perspective, but they can tweak that software. So that's a benefit to me. You guys might know about the flex radios. I've seen them at the HamFests. I've avoided paying for one yet, but that Moore's Law, I think, is gonna really take care of that. Again, it's all about, in that case, you're gonna have top of the lines specs out of a radio you might not expect, or features, like the way they use virtualization, abstract virtualization of a computer processor and memory. They're slicing it. You guys familiar with the term slices in their systems? They're giving you 4 radios. It might not have 4 receivers in it, but it's slices. They're virtualizing the hardware at a software level. It's incredible. We do it in the business, so this is the radio incarnation of that. There's some systems out there already that are probably taking advantage of some of this tech that's in these devices, like that mesh network, like the haven't heard too much about this one, but I've seen it. The WinLink system, to me, is an example of how the computers are actually figuring out what is my best path. They have a system in place, a network. How many different protocols is WinLink up to now, Glenn? Right. They're constantly putting in new protocols, new bands, new methods of communicating with their network, all software. And this is just a picture or an idea or example of the cognitive. I'll be honest with you, I'm still learning this too, but I always like to share something I'm thinking about. And I wondered how unlicensed band devices could cooperate with licensed band. Then I realized there is a central system that's feeding information, maybe via transmit. It doesn't mean these are transmitting on, even though that one kind of shows that. It might mean that this is where that stuff is being monitored from to figure out what might be the best path to get from one place to another. That's the whole idea behind that cognitive radio. Spectrum, some of the terms they use are spectrum sensing, spectrum management, spectrum sharing, and mobility. So, it kind of looks like work to me. I can go home and work, I can go to work, I can go everywhere to work, and laptops everywhere. Or my cell phone, the electronic leash. I have some demonstration here, and it's purely pictures. I wasn't going to drag my monster computer in here because I think I'd start throwing circuit breakers. So I did take some pictures and some ideas. So here is an example of the SDR Play Duo. It's $300. It's a dual receiver SDR running their software called SDR Uno. That's these frames right here. And if you notice, what I've done is went to 20 meters, and I've got the WSJTX software listening for FT8. All the rave right now, right? At least. So I zoomed in to the waterfall so I could see it on the SDR, adjusted all of my sights so I could see the whole thing, just like it does in its software, but it's more concerned with actually decoding or figuring out what those signals are, which is what this is. So how did I get this signal, which is a receiver, into this software? Those are two completely different things. Let's backtrack a little bit. We're digitizing the RF. We're running it through software, processing that using single sideband. And yeah, I can't see exactly. It's upper sideband on 20 meters. We're processing it through whatever filtering I got going on, and we're seeing it visually. But then there's something that has to get it here. Normally, I would take an interface out of my radio, plug it into an audio. Well, this is happening inside the computer. Okay? So no longer do I have an interface with a cable plugged in from the SDR, what it's receiving, and piping it to a radio or another computer. This is the same computer. Taking the AF, or audio frequency, that's being processed and pushed out analog again, from analog to digital to analog again, and then it's piping it into a software. Everybody get that? So there's a driver, that's happening on my computer called a virtual cable. So I just literally piped it through the audio frequency, started up the SDR with that listening, and said, let me see if FT8 can decode it. And sure enough, voila. So imagine some of the possibilities of that. Maybe if I have a laptop that's powerful enough to process what's coming out my SDR, I don't need to lug around 3, 4 pieces. Now it's one piece in a little box. An awesome idea to me, being able to take all of that horsepower because of Moore's law and then run it down to me carrying less stuff around possibly, even though I'd probably wind up carrying more. That means I can carry more, right? That's one of the demonstrations where I can pipe it into a software. Another demonstration that came up kind of appeals to me in my search to figure out what's out there. 101.9 with AFC turned on. It's a local radio station that's being translated into wide FM stereo. And this is that signal. You can kind of see the passband that I have, these dark areas. So this is the analog signal that I'm hearing. I'm listening to the radio station at this point, coming out of my, but what is this?
That's the digital form of it.
Okay, and yes, there's a, kudos to Dave Hartley, K50Z there. He's absolutely right. This is the analog signal that used to be for that radio station, and it still is. They're still broadcasting it, but along with it, they're also broadcasting a digital signal using an ubiquity decoder or encoder. The reason I'm bringing this up, we don't have to delve into all of that. That's happening whether we want, or not. But the reason I'm bringing this up is I didn't know that existed until I got this SDR and figured out that, wait a minute, I get this. What the heck is that? And then I realized, wait a minute, it's my truck. My truck outside has an HD radio in it. Is that what's happening? The answer is yes. They have 3. You notice there's only 2 sidebands here, but there are 3 stations or channels within 101.9 that are being broadcast. You can tune to 101.91. When the radio switches to HD mode, you can just switch to the next digital frame. So then it becomes 101.9-2 or -3. And what they'll do is they'll have different formats, kind of like cable TV. You have the classical music version, the classic rock version, and then light radio, which is what 101. Bottom line is I guess the term to use is multiplexing signals in here in this digital stream to give you a different format or a digital. HD radio is the official name for it. And the company who makes that product is called Ubiquity, with an I, not you. So here's an example. The only reason I brought all that, here's an example of why SDR is important to me. It's visual. Now I can see, oh, that's what they're talking about. And it makes me go try to figure out what to do about it, or if I can do something with that signal. But here's one of my favorite stories, just browsing. Same idea. I found a signal. I didn't know what it was, and I tried to figure it out with some pretty good success here. You can see the frequency here is 900 megahertz, 929 megahertz, and it was kind of bursts of signals. Now, I've heard many things like this before, but didn't know exactly what it was. So I started doing some research on the internet and found that it was, from what they were saying, it was the pager networks. You remember when we all used to carry pagers for our jobs or whatever. And I'm like, man, who's still using pagers, right? How do I?
50 and 450.
Who's still using that around here? And it's close to me because this was pretty good. I might have had a bad antenna at the time. 30, I forget what the dBs were. But anyway, so I did some more research and found, oh look, there's a pager decoding software on the internet that's free called PDW that actually decodes POC-SAG, which is what this protocol is. I figured all that out just from typing in the frequency and Googling it, and then figuring out what do I need to decode it is what I want to see. Then I used that virtual cable to pipe the signal into this software, and sure enough, it started decoding stuff. Well, and that was fascinating to me because I found this signal, I'm like, what is that? And because this was visual, it allowed me to figure it out, just doing basic research, go figure it out, how to decode it, and do it. And sure enough, there's always somebody who's done that already on the internet, in the Google machine. So that was a good story. I like that one. This is the All Hazards Radio service from the NWS, or NOAA, actually. NOAA All Hazards Radio. So the point of this one is I'm looking at that whole band. I wanted to see, I knew they had a network, the 162.50 range. They have a network of those transmitters all over the place. And I've always wanted to see what else can I hear? Is there some other channel? The squelch might not break for some of this on my cheaper weather radio, but I wanted to see what was out there. So I put it on a VHF antenna I have way up at 50 feet or so, and I started seeing all of them. So this is a case where visibility, I'm seeing the whole band to let me know what might be adjacent or around, what else is in that service. Okay, this one's interesting. The first SDR I ever bought was a cheap, old man compliant, $20 ADS-B receiver. It was a USB dongle. People might have seen them from New Elec, or they have different names. And then there was an up converter that came with it, or you could buy it to make it where it could hear HF as well. It's cheap. But one of the things I remember doing with it was realizing that I could listen to the airplanes that were flying over my house, beaconing or broadcasting two things. One, their position, their flight number, all kind of information. And another one was what looked like to me maintenance information. But this is a big use. The people who developed this software with SDR Play, I think Tommy actually interviewed the guy who wrote it, right? Yeah, there's a segment in our videos who he was talking to the person at HamFest. It happened to be the person who wrote this software. And he's saying, oh, I'm developing this next. Here's what we're doing next. They're not stopping. They're going to add those features in those softwares. This is called Dump 1090. I think 1090 has something to do with the frequency. Yep. And it's where you can basically see where these planes are in your area, and it goes and reports that to a local thing that's publishing the flight's information. So you see in real time what's flying over your area, what kind of plane it is, what flight it is, source, destination, all that information is being broadcast real time from the planes for all kind of different reasons for them. Collision avoidance, information between plane to plane instead of having to depend on some other central. This is just another example of what they're doing with this stuff. The last example is something that my buddy here in the back did during their field day in Jackson, where he was actually controlling his ICOM 7000 through an interface with the software, using it to visualize that whole band of, I guess that's 20 meters. And he also made some cheap old man compliant homebrew switches so he could listen to either the 7000's audio or the duos back here, right, George? Yeah. And he's got MFJ's switch that protects it, basically one antenna source coming into both your radio and the SDR. Right. And when you transmit, it protects the SDR from getting fried from the RF. It isolates it, basically. Plus, the control interface is here. It does an RF sense where it does that, I think you used your amplifier key switch to tell them when it was keying down. So there's all kind of little interesting gadgets to help you not fry your SDR, which is good. That might supplement, all these ICOMs and the new rigs, they have a little graph display of what might be out there, and you might have to hit the scan button 4 times. This is adding a real-time scrolling waterfall display, pan adapter, to a rig that don't have that. And he's looking at the band, trying to figure out who to go nab on field day. There's a bunch of references here that people can get wherever they put these presentations. That's what's driving me towards SDR. The different levels of nerd in me are screaming out saying, what else are we going to dig out of this thing? And for how much less? So thank you guys for listening to me. Sure. Thank you, thank you, thank you. It was a higher level overview, and my buddy Carl Federowish is right now giving a talk at the La Quinta, much more technical side. Carl was a developer of sorts, programmer, and he goes much more in detail about those software components that act like the analog components than I do, because he's got the history and the career of doing that. So